be confusing. Okay, so this is our, so we have compression. So compression means it's pushing towards the structure. Tension means it's pulling away from the structure. Okay. So this is our moment. So when we add both of them together, right? When we add both of them together, this is what we observe. Okay. So when we add both of them together, oh, just nice. Okay. When we add both of them together, I'm going to try to shift this. My bad. When we add both of them together, right, this is what we see. 2, 2, 4. So this is your Y, right? So we will see a what? A shift. So I'm going to copy. The gradient will not change. Gradient will, sorry. You know what? I will just manually draw. So the gradient will not change. It's only the what? It's only the, it will shift to the other side. Okay, towards the right. Okay, right? So what you see now, okay, so again, this is our point alpha. And over here, this is our point beta. So you see a shift. Now something changes. Okay. If you look, I want you to focus on the y-axis now. I want you to focus on y-axis now. Okay, I want you to focus on the y-axis. Okay, I want you to look on the y-axis. Right. So over here, focus on the y-axis, yeah? So when we just, if loading is centric loading, which is just only if only under centric loading, which what we have always been doing before, right? The centroid, comma, centroid and neutral axis is at the same what? Position. Right? If only we have what? Stress X is equal to my over I. Why do I say that? So remember, I told you this is a centroid, right? So we draw zero line centroid, and this centroid over here, the stress is also equal to what? The stress is equal to 0. Okay, so this is only under what? Centric loading. But when we have eccentric, during eccentric loading, which is this case over here, where stress X is equal to Px over A plus by mz over izz multiplied by y. Sorry, this is also, I better write properly. Some of you might say, Eugene, why it's not the same? Okay, mz over izz multiplied by y, right? So for this case, what do you realize? Anyone, what do you realize about this case? What is the difference now? Can anyone tell me what you see that's different? There is a shift, right? So what does this shift do to your stress field relative to the centroid? Hello? Are you there? Or is it I cannot hear you? Can anyone tell me what's going on? I can hear you. Anyone?
Isn't 0 anymore?
Yeah, right. You see down here, you have a shift. Okay, you guys are alive. Good. Don't die on me yet, okay? So I'll draw this green line now. So now this is your what? This is your neutral axis. Right? And then now this is your what? Centroid. The centroid is discovered based on what? Geometry. The neutral axis is all dependent on what? Stress field. Okay. So the neutral axis over here is based on stress. Right? It's based on stress. The centroid is based on what? Geometry. The centroid over here is based on geometry. I want you to see that. Okay. So there will be a shift. Okay. So during eccentric loading, the centroid and neutral axis position are different. You can see for this case, right? So when it is centric on your left hand side, what you'll see, right? You'll see your neutral axis and centroid are at the same location. Okay. Then where's eccentric loading? So I'm going to highlight for you centric. Okay. When it's eccentric loading, you see a shift, right? So over here, right over here at this point over here, right at this point over here, stress is equal to, right? So you see the shift down here. Okay. Now what if now? Okay. What if now? Right? We are going to change our what? What if now we are going to change our loading? Okay. So now you will see our loading initially was like this. Now what if I'm going to change the arrow now? So what if now we are going to do this? Okay. So let me look at. Sorry to move things around like crazy. Okay. What if now the structure is still the same? The structure is still the same. Wait, let me see. Is it the same? I can't remember now. No, it's slightly different. I'll draw this longer a bit. Okay. So this is still our point C. Right? Now, what if now our P go in the opposite direction? Right? And why am I showing an example for you on this is what if you flip the arrow around? Okay, I'm very infamous for doing that, yes or no. In the exam, I'll just change the direction of the arrow. Okay, what if the arrow is flipped around? Again, don't memorize the direction based the sign. Okay, you have to analyze. So again, you're going to analyze DC. Okay, right? So now action equal to what? Reaction. So this is now your what? Px. Okay, so now your axial loading now at point P goes in the what? Opposite direction. Okay, so because point C is a reference or fixed point, right? And then we have a certain distance D, right? And then we have a certain distance of the centroid E now. So what will happen now is the moment now, right? Moment now will be rotating this way. Okay. So when that's the case, right? When that's the case, what's going on? So this is now our compression. Over here, this is our what? Tensile. So over here, this is our moment at point C, right? That's how it's going to act. So we still don't change our sign, okay, our location. So this is still our alpha, and then this is our what? Beta. Yes. So what is going on now? So now if we are to write this out, So we write out that stress X at point alpha now, right? So now we know that is Px is minus, is inducing a what? Compression, right? And then alpha is going to see tension due to the bending moment. That's why it's plus now. So you have mz over izz multiplied by y. Okay, so yeah, just multiply for y. Okay, so you can see it changes now. So if you look at the one before, right? You look at the one before, right? Over here, this and this, it changed in direction now. The sign changed. I want you to see that, right? The one that I'm highlighting now in yellow, right? The sign changes. Okay, this is because of what? We flip the arrow, yes or no? So now if we look at stress X beta, right? So this is minus Px over A. You see under compression. Now, right, beta is below the centroid. So now this is minus mz over izz multiplied by what? Y. Okay. So when we're going to sketch this now, right? When we're going to sketch this now, right? So it will look like this now. So now, if I'm going to sketch this, right? So this is our stress X. Okay, so this is our X. And then this is our Y. Okay, I'm going to do two things for you guys. Okay, so I'm going to do different color. I'm colorblind. So we know the first line over here, right? So this is your minus Px over A line. Okay, right? This is your minus. And then if this is your point alpha, and down, sorry guys. Oh, sorry everyone. So this is your point alpha. And this is our point beta. So due to moment, we know that alpha now will be positive. Yes or no? Due to moment. So I'm going to draw this based on moment. Okay. Right? So this is now based on stress is equal to my over I. Okay, so this is based on bending moment. Okay, so this is how the stress look like. And then when you add both of them together, we're going to see a shift, right? So this plus that, you're going to see a shift. Okay, so this is the shift that we will see. Right. So this pink line that we draw now, this is your stress X is equal to Px over A plus by My over Iyy multiplied by Z. Right, there's a shift. As I said, don't worry about the sign, okay? So from here, we know that at the top, this is how the stress field will distribute. And then over here, you'll be going compression. Again, what we see is this line over here, right? This is the centroid, right? And then the one over here. Wait, I need to find green. So this point over here, this is our neutral axis. Okay. So that is the most important thing about this topic over here, right? Is the shift in the neutral axis and the right directions of the moment. Okay. So now let's look at an example. Okay, any questions so far? Anyone? Let me see. There's a question been raised, which I did not see earlier. I do apologize. Not zero anymore, Montoya, you're right. Okay. So the next one, we're going to look at an example. Yeah, we're going to look at